Okay, you guys, we are going to talk about phasors now and the way to diagram them. So we've already got the notation. It's how do we make a diagram? And what you do is you select a variable as a reference. So that will go along the x-axis. You could make the current the reference. And here's how you draw that. This is the diagram right here. The current is equal to j omega c times the voltage. So the voltage is along this axis. The current times the resistance is this, the current is this length. It is in phase with the voltage. The current through the capacitor is this length, the length of this arrow. And this is what it would be, the admittance times the voltage. Inductor, similarly, we have an arrow going down because this becomes a negative J. So this is the negative 90 degrees. This is the positive 90 degrees. It's in the complex plane. Imaginary part of the number, real part is over here. Okay. If inductance dominates, you're going to have a negative phase angle because this arrow is going to be bigger than this one. If capacitance dominates, just the opposite. This arrow is bigger than this one. And as frequency changes, the high frequencies, at high frequencies, the admittance is small. Other way around. At low frequencies, the admittance is big. When omega is near zero, this makes this a big number, a big negative number. There we go. And that's for low frequencies. And as frequency goes up, the circuit will switch from inductive to capacitive. As frequency goes up, then this current becomes the biggest. And this arrow here for capacitance goes up. The length from left to right is always going to be the I times R. Okay. So we can do a phasor diagram for this circuit. Let's go ahead and do that. So we have the voltage, Vs, and we want, let's see, we have a series circuit. So does it make sense to think of current as the reference or voltage as the reference? V equals I times the impedance. So I'm going to take voltage as the reference. Oops. And I'm going to put the resistance, and that's 4 ohms here. And the inductance at 377 megahertz and 15.92. Well, that's just going to be J omega L. And let's figure out what that is. Okay, picking up here, I didn't show you these calculations. Pretty straightforward. Felt that wasn't really necessary. Omega L, entered C, the capacitance. found out the impedance of the inductor and impedance of the capacitor. Okay. Impedance of the inductor. So it's approximately +6 in the inductance direction and -2 in the capacitance direction on the imaginary axis, and 4 on the real axis. So we're going to have approximately a 45-degree angle. Okay, so 4 ohms, and what did I say? 6 ohms inductive. Yes, 6 ohms inductive. So I might as well, this is the inductive arrow. This is Z sub L. The capacitance arrow is about half that length, Z sub C. We add these together. This is approximately, did I say 3? Let's see. No, 4. Z sub C is 2, Z sub L is 6. So this is about 4, 4, and my scale is rotten. Trying to, there. So this is more like it. This would be the Z equivalent. Let's see what the book says. So they write down all the numbers. V equals the sum of the 3. And draw all the phasors. Their diagram looks a lot like mine, as you can tell. They chose current as the reference. I should have chosen current. That is better. I was thinking Z times the impedance times the current gives you the voltage. You know, I was thinking along these lines. And they said, no, 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 you can change current. You can change current. So I should have chosen the current to be my reference. Because Z times I will give you the voltage. And of course, Z times I gives you voltage of the inductor. Z times voltage across the resistor. Voltage across the capacitor. And then this is voltage of Z times I equals voltage of the source. Okay. Put in numerical values, get it all straightened out, and they come up with exactly 45 degrees. Okay, I wonder if New Octave is going to tell me that. Let's go for it. See, that'd be 4 plus ZC plus ZL. That's the total impedance. And that looks really close to 45 degrees. Arg of answer times 180. Oops. Divided by pi. There we go. 45.01 degrees. A little rounding error, obviously. I didn't realize it was almost exactly 45. Okay. Okay. If V is this, an amplitude of 12 at an angle of 45 degrees. So instead of going along the horizontal axis, V is going along the 45 degree angle. I would be 45 degrees, excuse me. I is at 45 degrees. The total Vs, there they're drawing it. I is at 45 degrees. Vs is pointing straight up and down. You rotate this diagram, by 45 degrees is what you're doing. Okay. Figuring out all the VCs, VLs, VRs, and then final VS. Now, the frequency at which the two are in phase, I'm going to save that for the next video.